We're still in Chapter 10 in Algebra 2 at 10.5a. We're going to start talking about parabola, and I'm going to show you how to find a vertex, focus, and directrix and graph from a given equation. And I have 3 theorems for you. If you haven't seen, or if you've missed some of the videos in Chapter 10, you can click on this description to figure out where you got lost or confused or what you missed. When we throw a ball or when water comes out of a hose, they follow a parabolic path. They arc, don't they? And some equations of second degree of graphs that are parabolas. Here's our formal definition. A parabola is a set of all points P in a plane equidistant from a fixed line and a fixed point F in the plane. And the fixed line is called the directrix, and the fixed point is the focus. So, what it's saying is that it's the set of all points P that are of equal distance from the directrix and the focus, okay? So here's our first theorem. A parabola with focus at 0 for x, p for y, and a vertex at 0, 0, the origin, has a directrix of y equals negative p. We first obtain the equation of a parabola with a focus on the y-axis. The directrix is going to be parallel to the x-axis. This dark orange line is the directrix, and it's parallel to that x-axis, isn't it? The equation y equals negative p, so this directrix is going to be in the negatives, and the vertex is at the origin 0, 0. See where the vertex of our parabola is? It's right at 0, 0, okay? So if we have the point P with coordinates x, y, we know from the definition of a parabola that we just read that FP equals PD. And using the distance formula to find the distance between 2 points, we have FP is equal to the square of x minus 0 plus y minus the square of y minus p. Now, if we solve this, if we solve everything here under the radical sign, we're going to get y plus p. So this distance, PD, is going to equal y plus p. We can square both sides of this, and we'll get x squared plus the square of y minus p is equal to y squared plus 2py plus p squared, okay? Now, we take this equation and we solve it for x squared. So we're going to start by using our addition properties and making additive inverses. So if we have a plus y squared here, we can do a minus y squared, right, on each side. So that eliminates those, all right? So now this is what we have. We have a plus p squared, so we can take away a p squared from this side and this side. Now we just have x squared minus 2py equals 2py. We can combine these two to one side by adding it on this side, and we get x squared equals 4py. This is going to bring us to our next theorem, in which the line of symmetry is x squared equals 4py. And if you take a look at this graph, here's F, here's P, here's line FP, here's P, here's D, here's line PD, see? And they're equal, they're equidistant, see that? So here's our theorem I was talking about. The equation in standard form of a parabola with focus at 0p, directrix y equals negative p and the vertex 0, 0 at the origin, and y-axis as the only line of symmetry is x squared equals 4py. For the parabola x squared equals y, we can find the vertex, focus, and directrix and draw the graph. Our equation is in the form x squared equals 4py. Now, since the coefficient of y is a 1, it's our buddy the invisible 1, isn't it? We get 4p is equal to 1. See? If 4p is equal to 1, dividing both sides by that 4 coefficient, we get p equals 1/4. So the focus is 0 for x and 1/4 for y. That's our focus right there. 0 for x, 1/4 for y. And the directrix is y equals negative 1/4. And the vertex is 0, 0, the origin. Okay? Right there. If the p value is greater than a 0, then the graph opens upwards. If the p value is less than 0, the graph opens downward, and the focus and directrix change side of the x-axis. So here are the we've got a directrix of y equals negative 1/4. So I made it so that it took 4 units to make a 1, so I could show the 1/4. Okay? See that? Here's our next theorem. We've got the equation in standard form of a parabola with focus x is p, y is 0. The directrix is x equals negative p. So if you remember here, it was y equaled negative p, right? Now we've got x equals negative p and the vertex 0, 0 at the origin, and x-axis as the line of symmetry is y squared equals 4px. Now if you look at what we had before, we had x squared equals 4py. Now we have y squared equals 4px. For the parabola, y squared equals negative 12x, we can find the vertex, focus, and directrix, and then draw the graph. And the equation is in the form of y equals 4px. See? So here's our equation again. Since the coefficient of x is negative 12, 4p equals negative 12, we can divide both sides by that 4 coefficient for p, right? So p equals a negative 3. So we know p equals a negative 3. This means the focus is negative 3 for x and 0 for y, and the directrix is x equals a negative of a negative 3, which means it's a 3. So we know this big green line is our directrix, and it's on where x equals 3. See? And the vertex is at 0, 0. See that? At the origin. Okay? We find 2 other points on the graph by substituting negative 3 for x. Choosing negative 3 for x is going to give us a perfect square for y squared. And that'll give us a negative 3, 6, and a negative 3, negative 6. See? So we have negative 3, 6, and negative 3, negative 6. See that? And if we know the vertex is at the origin, we can just draw the curve. See? All right? Boy, I know. I hope this wasn't getting too confusing for you. If you're really lost, maybe you can go back and watch a couple of the previous videos or watch this one again. But sometimes it takes time for things to really sink in. So if you give yourself a break and then maybe watch this a second time, you might be okay. All right? Our next video is 10.5b. We're going to talk about parabolas in the standard form by completing the square. We're going to find the vertex, focus, directrix, and graph a parabola by first completing the square. I'm going to add this to the Algebra II playlist, and I'll have a link to those previous 16 videos in this description. So you can just click on them and watch them and not have to go looking around, all right? Hopefully the titles of them will let you know what each video is about, enough that you know which one to click on, okay? I hope you're doing okay. Keep trying. I'm rooting for you. I'm proud of you. Bye.